So in this video we're going to be drawing a speed time graph. A person starts from rest at point A. They accelerate uniformly for 5 seconds when they reach 3 meters per second. So before we go any further, key terminology here, accelerating uniformly, that means that it's a constant acceleration. Okay, and the way that that looks on one of these graphs is that the speed time graph will be a straight line. Okay, so if the acceleration is uniform or constant, those two terms really mean the same thing, then there will be a straight line on the graph. They continue at this speed for 4 seconds. They then slow uniformly, there's that word again, to a stop in 2 seconds. Draw a speed time graph of the person's motion. Okay, so again, I'm going to be drawing this, I'm not going to be drawing this perfectly accurately, just so we can kind of get an idea of what it would look like. That doesn't look very straight to me. Let me just try that again. That's a bit more like it. Okay, right, so time in seconds, and this is speed, and that's in meters per second. Okay, so first of all, they start from rest. Now, when something's said to start from rest, that means that they are travelling at 0 meters per second. Okay, so they're not going anywhere. When you're at rest, you're stationary. They accelerate uniformly for 5 seconds when they reach 3 meters per second. So 5 seconds goes by and we've reached 3 meters per second. Okay, so here's 3 meters per second. 5 seconds has gone by. Okay, so let's draw a point there. And the reason why this is a straight line, remember, is because the question says that the acceleration is uniform. So it's a constant acceleration. And so that's why you've got that nice straight line. They continue at this speed for 4 seconds. So for 4 seconds, so that brings us up to 9. We remain at 3 meters per second. So this is what happens when you can jump from the distance or displacement time graphs to speed and velocity time graphs. Once you've done distance displacement time graphs, you're looking at those horizontal sections like this, and you're thinking, oh, that means that we're not going anywhere, right? So for displacement or distance time graphs, that's what that means. Okay, you're not travelling anywhere for that period of time. Here, for a speed time or velocity time graph, that horizontal line is telling me that my speed is constant. So the person is travelling at 3 meters per second for those 4 seconds. It's just that they're not getting any faster or slower. Okay? Then they slow uniformly to a stop in 2 seconds. So in 2 seconds we're going to be at 11, and they're slowing to a stop. So that means that their speed is changing, and it's uniform, so it's a straight line, and we're getting back to the time axis. Now again, on a displacement time graph or distance time graph, getting back to the time axis meant that you got back to where you started. That is not the case for speed time graphs or velocity time graphs. Getting back to the time axis here means that your speed or your velocity is 0. So when you are on the time axis, that means you are stock still, you're stationary. Okay, you're at rest. So here is my speed time graph for this scenario.